Hey team, welcome to this complete course.
Hello everyone, my name is Abhishek and welcome back to my channel. Today is day 0 of AWS Zero to Hero series, and in this video I'm going to
Hello and welcome back to Learn Linux TV, and also welcome to my brand new Bash scripting course. In this series, what I'm going to do is teach you everything that you need to know in order to get up and running when it comes to writing Bash scripts. But you might be thinking, why exactly would I want to write a bash script? Well, we as Linux administrators or DevOps professionals are going to be running quite a few commands. And eventually, we're going to run into a situation where we have a series of commands that we need to run every now and then. But if we're going to be running the same set of commands over and over again, then why not automate it? Why would we want to manually run those commands every time we go to complete that task? And that's where bash scripting comes in. At its lowest form, bash scripting is just a way to have a bunch of commands run one after another, commands that you save in a text file and then execute as a script. But that's not all that you could do in bash. Bash has all kinds of cool features, such as if statements, while loops, the ability to have variables, and if I didn't know any better, I would say based on that description, it almost sounds like bash is a programming language.
Hi, I'm Andrea Crawford with IBM Cloud. We're going to talk today about DevOps. As the name implies, DevOps is about bringing together two traditionally contentious groups within IT organizations. Application development, which has primarily been measured on the number of changes, features, and defects fixed that are able to be pushed out into production, whereas IT operations and their success is primarily measured on system stability, availability. So we have one group with pushing more changes and another group that's saying, don't push any changes. So let the fireworks begin. DevOps transformation is an important part to our clients' transformation strategies in general, particularly because of two main benefits. One of those being velocity. Velocity in terms of how quickly products or applications can be piped through this release pipeline. The second benefit, quality. It's not enough just to be quick in terms of how fast applications are delivered, but we also must be cognizant of the quality of what gets delivered on the other end of that pipeline. Digital reputations are at stake here, so quality and velocity both need to be balanced. The war between application development and IT operations really has one big loser, and that is the business. Because you see, the benefits are really going to manifest themselves in terms of business agility through being responsive to consumer demands, to changing market conditions, and basically improving overall time to market of what an enterprise can deliver to its consumers. If you were to think of application delivery as a supply chain or a pipeline, we really have this notion of ideation, user stories, what should be delivered in terms of adding value to the business and its consumers. So we have ideation over here. This is also in the form of user stories, work items, and the like. Then we have the coding piece. This is all about programming the idea from the user story. And then we have build. This piece here includes unit test cases, packaging of the code into executables, and run times that will actually be then deployed on some sort of runtime environment, be it bare metal, virtualized environment, or the cloud. And then we have manage. And this is all about addressing what happens to an application once it lands in its runtime environment. And this is primarily focused on production, but it can also be management in terms of what you have in dev, test, pre-prod, and the like. And then to round out the supply chain here, we've got learn. And this is all about continuous improvement. So not only do we need to understand, are we getting faster as we deliver applications, but is the quality improving too? So we want to make sure that our benefits are being achieved throughout the pipeline here. So if we were to identify the use cases for how to increase velocity and quality in the pipeline, there are really three primary use cases. The first is optimizing the core. By core systems, I mean those systems that are deep within the enterprise. These tend to be monolithic, legacy, big systems of record. Typically, these applications are very difficult to modernize, refactor, and the like. DevOps for the core often looks like retrofitting automation in situ so that we can optimize what we've got. The second use case is about unlocking the legacy. So this is all about addressing culture, ways of working, and bringing development and operations together in new ways, integrated multidisciplinary teams. And this amps up any kind of automation that we could have done in the core. And then the last, unleashing the digital. So with the maturation of cloud-native apps, 12-factor, Kubernetes and Docker, we're all about continuous delivery from ideation all the way through to continuous improvement and rounding back to the beginning. So what we learn that we can do better, we feed it back into the pipeline. This is all about modern applications delivered by modern teams on modern platforms. So if we were to sum all of this up, DevOps is all about people, process, and tools for the benefit of business agility. Thanks for watching this video. If you have any questions or comments, be sure to drop a line below. If you want to see more videos like this in the future.
So DevOps is more like what I understand is like whatever we have the idea, like we will put into the code, then we build and deploy it, like before the production, before the user can use, and we can manage and learn about the mistake and all, like what we have to better it and do the cycle again, the idea what we get the code. And yeah, I think that's what I understand. What about you guys? Like what you understand of DevOps? I'm just learning. Yeah. That's phone. Okay. Tecton and Jenkins. What's the difference? I really don't know. Let's see what's the difference. Let's find out.
Have you ever wondered the differences between Jenkins and Tecton? Hi, I'm Christine, and today I'm going to talk to y'all about the differences between the two. Two CI/CD tools that have the same goal, just achieve them in different ways. Let's start with the basics. To understand Jenkins and Tecton, we first need to understand continuous integration and continuous delivery, or CI/CD for short. CI/CD is the process of automating software development through testing, building, and deploying applications. Jenkins and Tecton are two CI/CD tools designed to create what is called CI/CD pipelines. To learn more about continuous integration and delivery, check out the videos linked below in our description. But for today, I'm going to talk to you guys just about the similarities and the differences between the two. Let's start with Tecton. To understand Tecton, we first need to understand Kubernetes. Kubernetes is a container orchestration platform designed for automating application deployment, management, and scaling. Tekton runs on Kubernetes, allowing you to work with your CI/CD processes on the same cluster as your applications. This allows you to easily scale your workloads simply by adding nodes to your cluster. Tekton comes with a set of Kubernetes custom resources, giving you the building blocks to easily configure and manage your pipelines. You can automate Tekton either through the command line or through the Tekton UI in the browser. All right, now let's get into the architecture. So I'm going to start by giving a simple example to explain CI/CD pipelines better. Let's say you have an application that you want to deploy into production, and you want to automate this process by using Tekton. To keep it even simpler, you're going to run the following procedures on it. You're going to want to test your application, build it, and then deploy it. Each one of these operations becomes a step, which is the smallest building block of Tekton. Steps are where you can specify your commands, your arguments, your images to execute your processes. Once you've created your steps, you can organize them into what is called tasks. And a single task, you can have one step or multiple steps, depending on the order and sequence you put them in your files. So a task runs on basically a pod. And a pod is a single instance of a running process on your Kubernetes cluster. But we're not going to get into pods or clusters today. If you want to take a deeper dive, again, check out the videos linked below in our description. So the great thing about tasks is that once defined, you can reuse them in any pipeline you want. So say I have another pipeline that I'm working on that's dedicated solely to testing applications, and I want to use this test task because it has exactly what I'm trying to do. All I would have to do is reference the task name in my other pipeline. No need to rewrite anything or duplicate it. All right, so that brings me to the next topic, which is pipelines. And pipelines are a way of further organizing your tasks by controlling the execution of them. Pipelines allow you to organize tasks concurrently or sequentially, depending on the order they're placed. And pipelines and tasks are Tekton custom resources that allow you to control what gets inputted and what gets outputted from the tasks. Or further organizing your tasks by controlling the execution of them. Pipelines allow you to organize tasks concurrently or sequentially, depending on the order they're placed. And pipelines and tasks are Tekton custom resources that allow you to control what gets inputted and what gets outputted from the tasks. For example, an input would be the source code of your application that you're running through the pipeline. And an example of an output would be the image produced from your build task, okay? So inputs and outputs, these are called pipeline resources. And you can define them in your tasks or your pipelines, or you can put them in their own file, depending how organized you want to get. Okay. So pipelines organize the execution of tasks, tasks organize the execution of steps, and steps execute what you're trying to do. How can we automate this process even further? What fires off our pipeline? So a concept called a pipeline run triggers our pipeline, and you can declare that in the trigger template. And Tekton triggers allow you to detect and extract information from events from various sources that allow you to execute your tasks and pipelines. So what exactly does that mean? An example of an event would be, let's say we want to fire off this pipeline every time one of our developers commits changes to the code. There's a concept called the event listener, which listens to specific events. In this case, it will be listening to our developer committing code. Once that happens, it will pick it up and it'll fire off our pipeline. All right. So as you can see, Tekton, its process is very structured. To put it even more visually, each one of these concepts is just a file. The event listener, the trigger template, the pipeline, and each individual task is its own file, a YAML file to be exact. And that's one of the biggest features of Tekton, is that it's object-oriented, it's modular, it makes it very easy to reuse and customize and organize, and it's super flexible, okay? So I'm going to touch on one more thing before we get into Jenkins, and that is storage. How or where does Tekton store its CI/CD data? The answer to that is workspaces. All right, so workspaces, or let me back up. When we think of storage for Tekton, think of basically a very large file system, okay? And workspaces allow tasks to declare part of that file system to use for storage. What are we storing? The inputs and the outputs throughout this whole process. To take it a step further, there's a concept called a persistent volume claim, or PVC, which lets you specifically define the location of that storage volume. And it lets tasks share them amongst the process. And you can typically define these in the trigger template. One more thing that you can also define in our trigger template is service accounts. And service accounts basically handle secrets or authentication with Tekton. So you've got passwords, you've got tokens, you've got SSH keys, and you want to make sure everything is secure before you run your steps. Tekton runs this credential initialization on each pod before it executes steps, keeping your whole process secure, which is very important. All right, so let's get into Jenkins now that we've got a good understanding of Tekton. The biggest difference between the two is that while Tekton runs on Kubernetes, Jenkins runs on its own servers, or VMs, virtual machines. So a part of Tekton running on Kubernetes means that it's made up of many different languages like Node, Python, Ruby, Java. Jenkins, however, is based solely on Java. You might be wondering, how can Jenkins even stand up to Tekton if it only supports features written in Java? The answer to that is plugins. Jenkins plugins extend the capability of projects written in languages other than Java. So say, for example, you want to use a version control system like GitHub. You would need to install the GitHub plugin on your Jenkins machine to work with it. Super easy to install. There's over 1,000 different Jenkins plugins, and you manage them and install them through what's called the Jenkins UI. Similar to Tekton, you can work with Jenkins through the UI or the command line, but mostly people use the UI. And on the UI is where you can manage your pipelines. Okay? So in that sense, it's very similar. But when it comes to the file structure, that's where they differ. Jenkins stores its configurations in what's called a Jenkins file, which is one large file, like so. So going off the same example I used over here, you've got an application that you want to deploy to production and you want to automate this process, but this time using Jenkins. What you would do is you'd create a Jenkins file and you'd come in here and I'm going to use this. You'd come in here and you'd declare your Jenkins pipeline. You want to test, make sure there's no errors or bugs. You'll want to build it, and then you'll deploy it. And over here in Jenkins, they're referred to as stages, whereas Tekton, they're tasks. And within each of these stages, you'll have your steps, which is really the meat of what you're trying to do. It's where you have your scripts, your commands, your arguments, parameters. It's held in the steps. So as you can see, looking at the structure, it's already a little different. We've got a 3-part pipeline defined in one file, while over here we've got about 6 different files. So the Jenkins file lets you configure not only your pipelines, but you can do a lot more other things in here. For example, you can define functions like exporting archives or security functions that you want to run throughout your process. There is methods. For example, for authentication, there's a method called credentials, where you would define in here. And this deals with secrets and authentication. For firing off the pipeline, similar to the event listener in Tekton, there's a concept in here called webhooks, which, very similar, you would program it to listen to specific events. For example, your developer committing code changes or creating a pull request. You'd define it like so. And once that event happens, your webhook would fire off your pipeline. Okay, so storage. Conceptually, Jenkins and Tekton are pretty similar. Jenkins uses file systems just like Tekton. But when we think of storage with Jenkins, they organize their directories a little different. So Jenkins has this home directory called the Jenkins home. And inside this directory, you'd have a lot of other directories where you'd store your build logs, your configurations, your artifacts. For example, there's a plugin directory where you'd store your plugins, or you'd have a secrets directory where you'd store your secrets. But most importantly, I think the workspace directory is where you'd work with the most. And the workspace directory is your working directory wherever you run your pipelines. So every time you run a pipeline, its build generates some artifacts, which, think of it as files or images. It's kind of like outputs in Tekton. And you have these artifacts and you want to use them in your next run or your next stage. And so you got to save them in your workspace so that they're not wiped out completely with the next build. You would do so by storing it in your workspace or archiving it elsewhere. Okay. So now that we've got a good understanding of the two, you can kind of see how conceptually Jenkins and Tekton are very similar. At the end of the day, they're just trying to automate the software development lifecycle. They're just trying to make a developer's life easier by getting rid of all of the manual steps as much as possible. Let's review a little bit about what I just went through, the biggest differences. So the biggest difference is, one, Tekton runs on Kubernetes, allowing you to easily scale your workloads to enterprise levels, while Jenkins runs on its own servers or VMs. It's Java-based, and it uses plugins to extend its capability. Number two, Tekton, it organizes each component of its pipeline into its own file, making it very organized and easy to pinpoint, while Jenkins uses one large Jenkins file to store its configurations and configure its pipeline. And then lastly, going off of this file structure, the fact that Tekton divides or organizes each file into its own entity, it allows it to be fully portable. So once defined, anybody in your organization can come in and reference your pipeline resource and use it in their own pipeline, making it very efficient for them and not having them reinvent the wheel every time. Whereas Jenkins, it's a little less organized and it's not as easy to pinpoint exactly what you're trying to reuse. So I hope that helped. Thank you so much. If you have any questions, please drop us a line below. If you want to see more videos like this in the future, please like and subscribe. And don't forget, you can grow your skills and earn a badge with IBM Cloud Labs, which are free, browser-based, interactive Kubernetes.
Hey there, and thanks for stopping by. My name is Bradley Knapp, and I'm one of the product managers here at IBM Cloud. And the question that we're going to answer today is, what is the difference between DevOps and SRE? This is a question that I hear on a fairly regular basis, not just internally, but from external customers as well. And it's one that we'd like to help you walk through so that you can really figure out what makes sense in your organization. And I think the answer is probably going to surprise you a little bit. Before we get into the video, I do want to encourage you to like and subscribe if you think that you're going to enjoy these things. Just click on those buttons. That way you get notified every time we come out with something new. So with that, let's get right into the question. And the question is, DevOps versus SRE. And so as we get into this, I think probably the most important thing to understand is this isn't a versus question. You don't have to have one or the other. As a matter of fact, I would argue, and I think that many people would agree, that SRE is actually an essential component of DevOps. And DevOps, a good properly implemented DevOps method, leads to the necessity of SRE when it comes time to deploy. They're two sides of the same coin. And so that's obviously going to lead to a little bit of confusion because DevOps is the development methodology, right? It's all about integrating your development teams and your operations teams. It's about knocking down those silos between them. It's about ensuring that everybody is singing off the same songbook, and that's very important. And SRE is in charge of automating all of the things and making sure that you never go down. There are really two parts of the same group. And so let's look at the differences, right? Because they do have some differences. Probably the first and largest one is that when we think about our DevOps side over here, right? DevOps is about core development. The DevOps guys, particularly your developers, they are doing the core development. They are answering the question, what do we want to do? They are working with product, they're working with sales, they're working with marketing to develop, design, and deploy. What is it that we do? They're working on the core. SRE, on the other hand, they're not working on the core. What they are working is the implementation of the core. They are working on the deployment. And they are constantly giving feedback back into that core development group to say, hey, something that you guys have designed isn't working exactly the way that you think that it is. So if we were to break that down a little bit more, they are helping the DevOps group, our SRE group is helping the DevOps group to break down even more of those silos. If you want to think about it this way, DevOps is trying to develop the answer to how do we solve this problem? SRE is saying, how do we deploy and maintain and run to solve this problem? It's the theoretical versus the practical. And ideally, they're talking to each other every day, right? Because SRE should be logging defects. They should be logging tickets back with development, but probably most importantly, they need to understand that they have the same goals. These groups should never be aligned against one another. And so they do have to have a common understanding. Let's talk about one of the most important parts, right? We're going to talk about failure. Because failure is not necessary. Failure is just a way of life. It doesn't matter what you deploy. It doesn't matter how well it goes. It's going to happen. And so when we talk about failure, everyone involved needs to understand that there's going to be some level, right? There is a failure budget or an error budget where things are going to go wrong. And what happens when things go wrong, that's what figures out whether or not your organization is working. Because your SRE team, when it comes to failure, they're going to anticipate it, they're going to monitor it, they're going to log it, they're going to record everything. And ideally, they can identify a failure before it happens. They're going to have predictive analytics that are going to say, all right, this thing is going to go bad based on what we've seen before. And so SRE is responsible for mitigating some of those failures through monitoring and logging and doing the preemptive part, right? So we'll do the monitors, we'll do the logs. SRE is also going to lead all of your post-actual failure incident management, right? They're going to get you through the incident to begin with, and then they're going to hot wash it when it's done. They're going to lead that RCA, that root cause analysis. And after they have that RCA completed, and this is the most important part, they have to take that RCA data and bring it back over into dev and get some tickets open. You have to get dev online because you've got to, these are the guys who are going to solve the core problem. Some RCAs might be solved by SRE internally, right? They're going to spend 50% of their time writing, 50% of their time working. And so some of that problem, they may be able to fix directly, but sometimes that's not the case, right? Our RCA may have found a problem that only dev can fix. And that's all right. That's not a big deal. They're going to get that over here. Dev is going to implement, and then probably the most important part, right? So you're going to get that new feature. Dev is going to get that pulled together. They're going to get that new feature rolled out, and then they're going to pass that back into SRE, and they're going to say, hey, SRE, that problem that we had, we got a new feature for you. And then our guys on the SRE side, what do? They then have to take that feature and they have to figure out how to integrate it into their monitoring and their logging efforts to make sure that we don't get into another RCA for the same kind of a problem. So these groups, they are part and parcel of the same bunch. You really can't have one successful organization without another. And when it comes to figuring out a distinction, it's not something that you should spend a lot of time with. There are different skill sets, right? Core development, DevOps, these are the guys that really love writing software. SRE is a little bit more of an investigative mindset, right? You have to be willing to go out and do that analysis, figure out what things have gone wrong, automate all of the things. But there's a lot that they have in common. Everyone should be writing automation. Everyone should be getting rid of toil as much as possible because we just don't have the time to be doing manual tasks when we can put the computers in charge of it, right? Computers are not great at thinking on their own, but if you need it to do the same thing over and over and over again in exactly the same way, you can't beat computing for that. And so automation is key. You just have a slightly different mindset. DevOps is going to automate deployment. They're going to automate tasks. They're going to automate feature. SRE is going to automate redundancy, and they're going to automate manual tasks that they can turn into programmatic tasks to keep the stack up. And so, you know, when we talk about DevOps versus SRE, that's not the question. The question is, how do we build DevOps? How do we build SRE? And how do we be sure that they are always talking to each other? Because the institutional knowledge that SRE has so much of, if that doesn't get passed back into your DevOps group, you're never going to be successful. You're going to have a silo here and a silo here. And at the end of the day, both of these philosophies, core component is getting rid of silos. Freeing ourselves from those silos is what is going to make us all more successful. Thank you so much for stopping by the channel today. If you have any questions or comments, please feel free to share them with us below. If you enjoyed this video and you would like to see more like it in the future, please do like the video and subscribe to us so that we'll know to keep creating for you. Thank you for joining us today. My name is Bradley Knapp, and I'm one of the product managers here at IBM Cloud. And we've come to answer the question, what is Site Reliability Engineering, or SRE? And SRE is really the name for a new discipline that's actually an old discipline. It's a new name. It's only been around 15, 18 years. But the job itself has been around for a very long time. It's just evolved over time. And now we've given a formal name to the discipline and the job. And so the question is, what is SRE? What is Site Reliability Engineering? And so the way that I like to describe it is that it's really the collision